hazard, what do you mean by dynamic hazard, and in particular in static hazard, we have defined what is static 0 hazard and static 1 hazard. Can anybody define what is static 0 hazard? Yes? Can anybody define what is static 0 hazard? Yes? Yes, nobody. What is static 1 hazard and
So,
static 2 hazard?
so if the
Yes?
output is currently at logic state 0 and
Okay.
after input changes, the output momentarily changes to 1 before
Okay.
settling on 0, then it's
Okay.
static 0 hazard.
Static 0 hazard. Yes, you're right. So what is static 1? All of you can see there on the screen. Static 1 hazard is in response to any single input change for some combination of propagation delays, a circuit output may momentarily go to 0 when it should remain constant at 1. Then that circuit is said to have what? Static 1 hazard. Means continuously the output has to remain at 1, but momentarily if the output goes to 0, such circuit is said to have what? Static 1 hazard. I hope that is clear. What do you mean by static 1 hazard? Fine. And then static 0 hazard, you can see there is normally, we'll come back to static 0 hazard later. A brief explanation about static 1 hazard. You can see this. Normally, the static 1 hazard occurs when the circuit has the situation like A plus A bar. If you come across the situation y equal to A plus A bar, then the circuit will definitely have a static 1 hazard. Then you may ask how y equal to A plus A bar will have a static hazard. Right? For this, you can see this particular logic diagram for y equal to A plus A bar. So A is given directly to the OR gate, A is inverted and given to the OR gate. I hope the circuit diagram is visible for all. Is it visible?
Yes, sir.
Yeah. So normally when you come across the situation y equal to A plus A bar type, then what happens? You come across this static 1 hazard. So y equal to A plus A bar situation is illustrated here in this logic diagram. You can see there is a OR gate. A input is given directly to this OR gate and A is inverted and given to this OR gate. Right? Now, if you assume that say A is 1, when A is 1, A bar has to be 0. So for this period, A is 1, so A bar is obviously 0. Now at this particular instant, input A is changing from 1 to 0. When input A changes from 1 to 0, what happens? A is changing from 1 to 0, so 0 will directly apply to the OR gate. But when A had changed from 1 to 0, A bar should change from 0 to 1. But whether A bar will change instantaneously? The moment A changes to 0, A bar becomes 1? No. Why? Because of the propagation delay of this NOT gate. And because of the propagation delay of this NOT gate, what happens? The A bar will change to 1 after this propagation delay. After this propagation delay, A bar will change to 1. Instantaneously, it has to change to 1. But for this period, it will not change to 1. It will change after this delay. So for this interval, what happens? Both the inputs will become 0. Already A is 0. This also becomes 0 because of the propagation delay of this gate. And hence, the output Y of this particular gate for this propagation delay becomes how much? How much? The output will become 0. And then when A bar becomes 1, that time Y becomes 1. You know that normally when we come across the situation Y equal to A plus A bar, irrespective of what are the values of A, whether A takes 0 or 1, always the output should be 1. Always Y should be 1. But here in this waveform timing diagram, you have seen that for this particular interval, the output Y is becoming 0. Why this Y is becoming 0? Because of the propagation delay of this inverter. and such circuit is said to have what type of hazard? This is called as static 1 hazard. I hope the static 1 hazard is clear for all of you. Is that clear?
Yes,
All of you
sir.
understood what is static 1 hazard? Yes or no? Yes? Is it clear what is static 1 hazard and where it occurs, which type of circuit it occurs? When you have y equal to a plus a bar type of circuits, in that case, what happens? Output has to be continuously 1, but momentarily it becomes 0. Hence, the circuit is said to have static 1 hazard. Is that clear? Any doubts here? Because this is important question. Almost every question paper you can find, and you may expect this in your first CIE also. Okay? Any doubts? Yes? Is this clear? Static 1 hazard?
Yes, sir.
Okay. Then can you explain me what is static 0? If you understood static 1, just explain me what is static 0 hazard and it occurs in which kind of circuits? Yes, Aditi, can you explain what is static 0 hazard and it occurs in which kind of circuits? Like how I explain you static 1, can you explain me what is static 0 hazard? Yes?
So output may momentarily goes to 1 and
When
when
it's
it should
supposed to
be
be 0.
0.
Yeah, that is called as static 0 hazard. It occurs in which kind of circuit? Have you understood the previous one, static 1 hazard?
Yes, sir.
Then can you tell me static 0 hazard occurs in which kind of circuits? Yes? Static 0 hazard occurs in, like static 1 occurs in the circuit of type y equal to a plus a bar. Whereas static 0 hazard will occur where? Static 0 hazard will occur in a circuit of type y equal to a dot a bar. What is the output of a dot a bar? A dot a bar will always be 0 irrespective of what input A takes. When A take 1, 1 and 0 will be 0. When A takes 0, 0 and 1 will be 0. Always when you come across such situation A dot a bar, you come across a hazard, that is static hazard, called static 0 hazard. The same thing is explained here in this. Again, you can check what happens when A changes from 0 to 1. Immediately A bar will not change from 1 to 0. It will take some time, and for this interval both the inputs A and A bar becomes 1 and the output will momentarily go to 1. Hence this kind of circuit is called as what? What it is called as? Static 0 hazard. So I hope it is clear both what do you mean by static 0 hazard and what do you mean by static 1 hazard. Is that clear? All of you understood it? Similarly,
Yes,
dynamic hazard, already I have explained you. When the output of the digital circuit is supposed to change from 0 to 1 or 1 to 0, the output may change 3 or more times, then the circuit is said to have dynamic hazard. Right? So what is the main reason for these dynamic hazards? Of course, the gate delays, propagation delay, and it is like an inherent property of the logic circuits that they come across one of these three hazards, that is either static 0 hazard, static 1 hazard, or the dynamic hazard. Then the question is how to overcome these hazards or how to eliminate these hazards, right? So to overcome or to eliminate these hazards, many a time you need to introduce some additional terms. Some additional terms you need to introduce in the circuit, so that they will eliminate these hazards, and those additional terms which we are going to introduce in the circuit to eliminate the hazard are called as hazard covers. Is that clear? What do you mean by hazard covers? The additional terms in the logic equation that prevents hazards are called as hazard covers, right? For example, suppose if you consider this particular example, y equal to AC plus BC bar. then it can be shown that it is having a hazard. I'll come back to it shortly. Like how do you come to know that there is a hazard in the circuit, right? So that I'm going to explain you shortly. What is the method to check whether there is a hazard in that particular circuit or not, and if there is a hazard, how that hazard can be eliminated by adding the hazard covers. So for example, if you consider this circuit Y equal to AC plus BC bar, then we can show that it is having a static 1 hazard. And to eliminate that static 1 hazard in this circuit, we need to add one additional term, say like AB. If I add this term AB here in this particular circuit, then we get the expression Y as AC plus BC bar plus AB, and then we can say that the circuit is hazard free. So this additional term AB which we are adding is called as hazard cover, right? Just I have explained here what is the definition of hazard cover. As I already told, we have a procedure to check whether there is a hazard or not, and how we can add a hazard cover to it, right? So this is what the circuit I have shown. Now you can see here like B bar plus BC circuit. When the circuit has static 1 hazard, if A equal to C equal to 1, if you take this A equal to 1, C equal to 1, then it can be shown that when B changes, there will be a hazard, like the output when A is 1 and C is 1. What should be the output that you should get here for this circuit? A is 1, C is 1, right? B may be anything. Suppose if B is 0, here you will get 1, right? And if B is 1, here you will get 1. That means one of the two AND gates will get both the inputs as 1, and the output of this circuit F will be always what? Irrespective of value of B, when A is 1 and C is 1, the output of this circuit will be always 1. The output of this circuit will be always 1, but momentarily the output of this circuit goes to 0, which can be explained here. Hence the circuit is said to be what? Having static 1 hazard. So to eliminate this static 1 hazard, we need to add some additional terms, and those additional terms are called as hazard covers. Those additional terms are called as hazard covers. Now, what is the procedure to eliminate these hazards or to add the hazards, right? So before we add the hazard covers to eliminate the hazards, how do you detect that there is a static 1 hazard, and how we can eliminate that? I hope the screen is visible to you people. Detection of static 1 hazard is explained here, right? Hazards can be detected using a Karnaugh map. So we'll see how the Karnaugh map can be used to detect the hazards, right? So how we can detect the hazards in a 2-level AND OR circuit using the K-map method is explained here. What is the first step? You need to write down the sum of product expression for the circuit, right? Use K-map, get the simplified expression. Then you have to plot each term on the map. You have to plot that each term on the map, K-map. Then this is very important step. If any two adjacent ones are not covered by the same loop, a static 1 hazard exists for the transition between the two inputs, right? So what is the meaning of this? This is very important to detect the static 1 hazard. So you take this particular K-map. Normally, if you come across such type, what you do is you will form one pair of these two 1 and another pair of these two 1, and you will get the simplified expression as here you will get it as B bar, A B bar, and for this BC, A B bar and BC. This is what you are going to get the simplified equation, right? You will get the simplified equation, and this is what is the logic diagram you should suppose to get. But as I said, how you will detect the hazards present in this circuit? When you have two adjacent ones, and if those two adjacent ones are not covered in any of the group, then there exists a hazard, static 1 hazard. I hope it is clear. All of you getting it? See, normally we form these two pairs, but in this process what is happening? These two ones are adjacent. and these two ones we have not covered in any of the group. And since these two adjacent ones are not covered in any of the group, then in such cases, definitely there exists static 1 hazard. Then what you should do to eliminate that static 1 hazard? Whatever the adjacent ones are there, you form a group for that also. So you should form a group of these two one also, though it is not required, because already this one and this one are covered in other group. But because two adjacent ones are not covered in any of the group, we get a glitch or a hazard, and to eliminate that hazard, what we need to do is these two adjacent ones also should be covered in one group, and corresponding to this, whatever term you get, that term is called as hazard cover, which I explained just now. So what hazard cover you have to add to this circuit? Here it is C and A, so AC should be added to this. So this is called as hazard cover, and now it can be shown that this particular circuit will not have any static 1 hazard. If you take only this circuit, there is a static 1 hazard. Why? Because two adjacent ones are not covered in the groups. So to eliminate this static 1 hazard, these two ones should be covered in one more group, and corresponding to that, whatever product term you get, add that in this circuit, that is called as hazard cover. And when you add the hazard cover to this circuit, now this circuit will become hazard free. There will not be any static 1 hazard in this particular circuit. Any doubts here? All of you understood this? Yes? Is this clear? What is static 1 hazard? How a static 1 hazard is detected, and how the static 1 hazard is eliminated by adding a hazard cover. For that, simple K-map method you have to use. When you use a K-map method, if any adjacent ones are there and if they are not covered in any of the group, you should say that there exists a static 1 hazard. And to eliminate that static 1 hazard, you should try to cover those adjacent ones by introducing additional groups, and those additional groups product terms what you are adding are called as hazard covers. Any doubts here? All of you understood it? Yes? Is it clear?
Yes, sir.
Very good.
Yes, sir.
Bhavna, you understood it?
Yes, sir.
Good. Right. Now, if you understood how to detect a static 1 hazard and how to eliminate it, can anybody tell me what could be the procedure for detecting static 0 hazard and how to eliminate that? Yes? Can anybody give a try? Of course, I have not yet explained, but if you understood that detection and elimination of static 1 hazard, you should be in a position to explain how to detect and eliminate static 0 hazard. Can anybody give a try? Yes? Omkar? What could be the procedure to detect static 0 hazard and eliminate it by adding the hazard cover?
Sir, we have to add terms in the POS expression.
Exactly. So how you will get the POS expression first? Again, you have
Sir,
to
we
use
can
what? K-map. Use K-map and group zeros. Get the POS expression, right? And that POS expression will have static 0 hazard if two or if any adjacent zeros are not covered in any of the group. If adjacent zeros are not covered in any of the group, there exists static 0 hazard. That is what is explained here. You can just go through this, right? One example I have taken, F equal to A plus C, A bar plus D bar, B bar plus C bar plus D. And it can be shown that this is having a static 0 hazard. So how do you detect that there exists a static 0 hazard? So whatever the expression is given to you, map it into K-map. So this, I will map it into the K-map. When I map that into the K-map, I will get this kind of what a K-map will get. So there is one chord, there is another chord, and there is one pair. So corresponding to two chord and one pair, we'll get this answer. This is one chord, another chord, and one pair. So A plus C for this, you can see here. Here we'll have the common term, and that is A, and here it is C. So you should not write it as AC, it should be A plus C, because 0 is written as a bar, and the 1 should be written as bar here, and 0 should be written as it is in POS equation. So we have this. So how do you say that there exists a static zero hazard now? Yes, Omkar, can you explain? I have drawn for you. This is the expression given for you. As you said, we have to use the POS K map. I have shown here POS K map. And this is what is the circuit we have got. And we have to show that this circuit has a static zero hazard. How you say that there is a static zero hazard? When? Yes?
When there are two zero adjacent zeros, but they are not covered.
Not covered. So how many adjacent zeros are here in this K map which are not covered? Not necessarily always two zeros. If there are any adjacent zeros, and if they are not covered in any of the group, then you get static zero hazard. So here,
Yes.
which all zeros, those are adjacent and not covered in the group?
Sir, four are there.
These two. Like 1 0 is in this group, another 0, they are adjacent, but this is not covered in the group, right? So here one is there. Now this 0 and this 0 are also adjacent. Yes or no? This top
Yes, sir.
0 and this bottom 0, they are adjacent. So they are not covered. That is what is shown by this particular dotted line. Is that clear? This 0 and this 0 is not covered. Then this and this is not covered. Then this and this, they are also adjacent. Sorry. These two zeros are also adjacent. They are not covered. And at the same time, this 0 and this 0 is also adjacent. They are not covered. So definitely this circuit has static zero hazard. So how to eliminate that now? How do you eliminate it now? Yes, Sohan, are you getting it? This from this schema we can say that there exists a static zero hazard. Now how do we eliminate that? By adding hazard covers. Now how do we add the hazard covers? What are hazard covers? I should add here now. Yes? Yes, Sohan? Are you able to hear me? Right, I think he's not there. Shreya?
Yes, sir.
Yeah. What all hazard covers we need to add now here? I have understood there is a static zero hazard.
Yes, sir.
Now, what all hazard covers we need to add to eliminate this static zero hazard?
So we should make pair of those adjacent ones.
All pairs? Okay, no doubt. Of this and this we need to form a pair. Okay.
Yeah.
Then this and this we need to form a pair.
Yeah.
Yeah. Now
So
here
then-
these two are adjacent. We need to form a pair. But at the
So
same time,
Huh.
this and this is also we need to form a pair. So instead of forming a pair, here
We
you
can
need to
form
form what?
Chord.
A chord.
Yes,
Because
sir.
you have to form a pair of between middle two zeros and the outside two zeros. So instead
Yes,
of
sir.
forming two pairs, you can combine all four and you can form one chord
Chord.
so that you can eliminate the hazard cover. That is what is shown here. You can see it.
Yes,
All
sir.
of you able to see this? You can see this. Like here, you can see this. This is what is you need to form. Originally we were having only two chords and one pair. But now how many groups we got? Those three will be there as it is. In addition to that, one more chord and two additional pair you need to add. And if you add those two additional pairs, then you get, this is the expression, and this expression is said to have what? This expression is said to have what? Static zero hazard free circuit. There will not be any static zero hazard in this particular circuit, right? And then any of these dynamic hazards I have already told. I just don't spend more time on it. Just if you come across more than one transition, when there has to be only a single transition, in that case we can say that there exists a dynamic hazard, right? So I hope all of you understood what exactly you mean by static zero hazard, static one hazard, where static zero hazard occurs, where static 1 hazard occurs and how to detect the static 0 hazard and how to detect the static 1 hazard and how we can eliminate static 0 hazard and static 1 hazard. So any difficulties if you have in this particular part, you can ask me. Yes? All of you understood the concept of static hazard and dynamic hazard first, and then in particular, what is static 0 hazard and what is static 1 hazard. I hope all of you understood this. Any difficulties, any doubts in this, you can ask. Yes? If you have any difficulties or any doubts in this portion, you can ask me.